Today we'll take a look at some applications of factoring or word problems involving factoring. Start out kind of on the easy side and then we'll work to more difficult stuff. So in this case, you've got a certain number decreased by 7. When we don't know the number, we call that x. So we're going to decrease x by 7. And it's going to be multiplied by that same number, or x. And we're going to increase that by 7, and they say the product, which is a multiplication, is 51. So in this case, we notice we have a product of binomials here, but since it's not equal to 0, we can't set those two binomials equal to 51. We have to set this side equal to 0 and then get an x squared. We can FOIL this, and you'll notice you have x squared minus 7x plus 7x plus, minus 49. And that's equal to 51. Again, we'll notice that in this case, we get x squared. The middle term is going to go away. Minus 49 is equal to 51. Since there's an x squared in the problem, we're going to set aside equal to 0. So we'll take and subtract 51 from both sides. We have x squared minus 100 is equal to 0. You'll notice we have perfect squares here, so this factors into x plus 10 and x minus 10. And now we have that zero product principle, which says x plus 10 will equal 0, or x minus 10 will equal 0. So therefore subtract 10 to both sides. X equals 10, the negative type, and then add 10 to both sides, and we get x equals 10. So there's two possible answers on this problem. In the next example, we're talking about two integers whose difference is 3. So to say that, we could say we have the first and the second, and then to say their difference, we can say one is x and their difference is 3. So we could either say x plus 3 or x minus 3. I usually like going plus if I have a choice. So in doing this, their product's going to be 88. So again, I have x times x plus 3 is equal to 88. Again, you'll notice we have a product of two terms here equal to 88. We can't set each of those two equal to 88. We have to set aside equal to 0. First, we'll take and distribute. So I have x squared plus 3x equals 88. Since I have an x squared here, I want to set aside equal to 0. Subtract 88 to both sides. There will be no like terms on the left side. So x squared plus 3x minus 88 equals 0. I now need to find two terms that multiply to 88 and add to 3. 8 and 11 will do that. I need a positive 11 and a negative 8. Now I have a zero product principle, and we get x minus 8 is equal to 0, and x plus 11 equals 0. Add 8 to both sides. X equals 8. And then subtract 11 to both sides. X equals negative 11. There's two possible answers on this. Now notice it's solving for x. We have two numbers here, so this is the first number. If I add 3 to that, we get 11 in that case, so I get positive 8 and positive 11. And then if I add 3 to this, I get negative 8. So again, I have a number of negative 11 and negative 8. Two possible answers. This problem's a little more difficult. We're talking about consecutive even integers. We've done that before. So our first, since we don't know it, is x. The next even integer is going to be 2 away from that, so I have x plus 2. And it says the sum of the squares of two consecutive integers. So I have to square x, and then I have to square the second. So that's x plus 2 quantity squared is equal to 100. This problem is difficult, and this is usually what catches people here. I can't distribute a power, so I have to take and FOIL this multiplied by itself. Doing that, I get x squared plus 2x plus 2x plus 4 equals 100. And then you'll see, adding like terms, I have 2x squared plus 4x plus 4 equals 100. Since I have that x squared, I want to set aside equal to 0. Subtract 100, subtract 100, 2x squared plus 4x minus 96 equals 0. Here's an opportunity to factor out a 2, because that's a GCF. X squared plus 2x, 48 equals 0. I'm going to take and divide by 2 right now. So I get x squared plus 2x minus 48 equals 0. I need two terms that multiply to 48, add to 0. That's a 6 and an 8. 8 being negative. 6 being, oops, sorry. 8's going to be actually positive. 6 is negative. So 0 product principle will hold. X minus 6 equals 0. X plus 8 equals 0. Add 6 to both sides here. Subtract 8 to both sides here. So x equals 6. X equals negative 8. These are both even integers, so either one could work. I add 2 to the 6, and I get 8. And I add 2 to the negative 8, and I get negative 6. So those are my two consecutive even integers that will work in this case. So this product is geometrical in nature. It says we have somebody who has a 6x8 photograph. Those are usually rectangles, so let's draw a rectangle, like so. And one side is going to be 6, one side is going to be 8. He then wants to take and cut some of the picture equally on both sides. So I'll draw that so that the new area is half the original. So the old area is 48, new area 24. And we know that the area of a rectangle equals length times width, or base times height, however you want to put it. So what I have to do is determine what my new length and what my new width is. Well, I know that this part here and this part here are equal, but I don't know how much it is. So when we don't know what something is, we usually label that as x. So if I was at 6 and I'm cutting off x, this is 6 minus x. If I was at 8 and I'm cutting off x, that's 8 minus x. So for the new length and width, I have 6 minus x times 8 minus x is equal to my new area, or 24. Again, I'm going to need to FOIL this out, so that's 48 minus 6x minus 8x plus x squared is equal to 24. Subtract 24 from both sides, and then I'll also add like terms. I have x squared minus 14x plus 24 is equal to 0. I need two numbers that are going to multiply to 24 and add to negative 14. That's going to be a negative 12 and a negative 2. So x could either equal, or x minus 12 equals 0, which means x equals 12. And x minus 2 equals 0, which could mean x equals 2. So we have two possible answers for this, but we really don't. Because if I look at my picture, there's no way that I can have a x value of 12 because that would make this side negative, and we can't have that. So this is not really an answer. So my value is 2. Therefore, my new length and my new width are 4 by 6. And my cutout is 2. This is the answer they want. This would be the new dimensions of the triangle, or the rectangle. Again, another geometry problem. We have a rectangular garden. So again, let's draw a rectangle. Like so. And we're going to want to take and double the area by adding a strip around this. So in order to do that, I need to draw another rectangle bigger than the other one and make that dug up area roughly equal all the way around. So in doing that, we don't know how wide that dug up strip is. So again, we're going to call that x. But that x is now to all four sides. We know that the original garden was 10 by 15. And we're trying to double the area. Well, here again, we have an original, which is 150, and a new, if I'm doubling that, is 300. Just like the last problem, we have a length and a width. In this case, my length of the new figure, notice I start with 15, but I'm adding on this x and adding on this x. So I have a new length of 15 plus 2x, and my width, which was originally 10, I'm adding on this x and this x, so this is 10 plus 2x. And that's my new set of dimensions. So in this case, I have 15 plus 2x and 10 plus 2x is equal to 300. It's going to take, again, a foiling to do this, so that's 150 plus 30x plus 20x plus 4x squared is equal to 300. I will subtract 300 from both sides. Combine like terms, so that's 4x squared plus 50x minus 150 equals 0. 2 goes into all these. Instead of factoring it out this time, I think I'm just going to divide every term by 2, which is also a technique we can use. And I get 2x squared plus 25x minus 75 equals 0. This is a little bit more difficult of a factoring, although I know I have to have a 2x to lead and an x to lead. And now I need to find two terms which multiply to 75. But then when I do the inner products, I'm going to have to get a 25. So I can think of 15 and 5 is one option. So I'm going to use that. I'm going to put my 15 here because I get 30 when I do my outside and 5 when I do my inside. So you'll notice that if I have a positive 15 and a negative 5, that gets me 25 or 30, sorry, minus 5, which is 25. And there's my negative 75. So this is my multiplication that I'm going to use. Zero product principle exists, so I can say 2x minus 5 equals 0. 2x equals 5, and then x equals 5 halves. And then x plus 15 equals 0, and x equals negative 15. The x equals negative 15 is not a possible solution because we can't dig up negative space. Cross that off. So my trench around is 2.5 feet. So finally, we're going to do what's called a projectile motion problem. So I'm shooting a flare up from a life raft, and flare's path goes up and then comes back down like so. And we know it's shot with an initial velocity of 192 feet per second. We want to know how many seconds it's going to take for the flare to come back down. Now the thing about this is we have to be given an equation to solve this because you aren't expected to know that. So here's the equation we're going to use. And in this equation, t talks about the time, v is the initial velocity, which we can see is right here, and h is the final height that they're measuring. So if this comes back down and hits the ocean, that height is 0. We have negative 16, that's just part of the problem. We're looking for t, so we don't know that. And our initial velocity is 192. And we put the t in there again. So you'll notice in this case, we hope that something's going to factor out, and actually happens that 16 is a factor of 192. So I'll pull out a negative 16, and a t is also in common. That's a GCF. So I have t, and 16 actually goes into 192 12 times. So you'll notice we have a zero product principle. Again, we can say negative 16t equals 0, and t minus 12 is equal to 0. I can divide by negative 16. So t is 0, and then add 12. T is 12. So in this case, doesn't make sense that it goes up and comes down in 0 seconds. It's going to be in the air for 12 seconds. And that's all we've got.